Question 1. A series circuit is shown in figure 1.1. The resistors have values of 3 ohms and 6 ohms. Part A. On figure 1.1, draw the symbol for a voltmeter connected to measure the Am I supposed to redo this part? Yeah, I should do. Okay. Part A. On figure 1.1, draw the symbol for voltmeter connected to measure the potential difference across the 6 ohms resistor. Okay, here's the 6 ohms resistor. As we know, connection for voltmeter is parallel. So what you need to do is to set up the voltmeter in a parallel manner. So this is the symbol of voltmeter and it's in parallel with the 6 ohms resistor. Okay, done. Next, the part B. The ammeter reading is 0.20 amps. Calculate part 1. The potential difference across the 6 ohms resistor. Okay, we know that the current here is 0.20 amps. Now we need to find the potential difference, which is the V. We don't know that one, and we know the resistance 6 ohms. So with all the values informed, we know that V is equal to IR. So we don't know V, just let it be V. We know I is 0.2 amps. Multiply with R. R is 6 ohms. So you get, with the use of calculator, 1.2 volts. You need V. Okay, next. The combined resistance of the two resistors. So I shall put the combined resistors as RT is equal to the two resistors. Go back to this diagram again. You can see that they are connected in series manner. So in series, we're gonna total them up together. So we're gonna have 3 ohms here, add with 6 ohms. That will give you 9 ohms. So resistance is 9 ohms. Okay, the unit is already here. Okay, on to the next physics question. Okay, next, question 4. A nucleus of cobalt emits a beta particle to form a nickel nucleus. This is the equation right here. So you're asked to calculate the value of X in part A. Alright, so let me just highlight or put a box here. We're going to focus on the highlighted area since we need to calculate the value of X. So X, okay, this arrow we can substitute it as equal sign. Equal to 28. Okay, we have plus here but negative 1 here, so we can just put it in here. Plus negative 1. Plus and negative to become negative. So X is equal to 28 minus 1, which gives you 27. So X is 27. Okay, part B. State the nature of a beta particle. So a beta particle, we can see here there's a negative charge here. There's a negative charge here, so we know that it is an electron. Okay, next. Determine the number of neutrons in the nucleus of nickel 60. We are asked to determine the number of neutrons. So we know that neutrons is equal to mass minus proton. We know that the mass is 60 for this nickel, and we know that the proton number of this nickel is 28, which gives you 32. So the number of neutrons is 32. Part D. A nucleus of carbon 14-6C emits a beta particle. the half-life of this carbon is 5,700 years. Initially, a sample of wood contains 1 million atoms of this carbon. How long does it take for the number of carbon atoms in the sample to decrease to 250,000? Okay, so we know that the value of this, which is the half-life, is 5,700. Okay, half-life is equal to 5,700 years. So you start off with, initially, you start off with 1 million atoms. So you have 1 million atoms here. Okay. It's gonna undergo a half-life or decay here. So let me just put here a half-life symbol. So when it undergo a half-life, the number will go half. So this will become 500,000. Okay, did it reach 250,000? Nope. So let's let it undergo another half-life. So 500,000 divided by 2 will give you 250,000. So it has reached to this number. Now it requires 2 half-life here. So 2 half-life meaning that 5,700 years you have to multiply with 2 to give you 11,400 years. So your answer will be 11,400 years. Okay. Question 7. Two similar metal cans A and B are shown in figure 7.1. Here you have these two metal cans. Can A has a shiny white surface. Can B has a matte black surface. Both cans contain equal masses of hot water. Initially, the cans and water are all at the same temperature. Part A. Explain why the temperature of the water in can B falls more quickly than the water in can A. Okay. They're asking you why the can B, which has matte black surface, the temperature falls more quicker compared to this can. Okay, this is a factual question. So matte black surface actually emits heat radiation better than a shiny white surface. So that's how you're gonna explain part A. Okay, next part B. State the process by which the heat is transferred through the metal of the cans. Okay, so cans are solid. So the method or the process to transfer heat through solid is conduction. Okay, part C. Air around each can is heated and rises. Explain why the air rises. When air is heated, the volume of air expands. This causes the density of air or of heated air to decrease. Thus, the heated air rises. Okay, next. Okay, question 12. Figure 12.1 shows how the displacement of particles in a wave varies with distance along the wave. Here you have the graph. Use figure, okay, part A. Use figure 12.1 to determine for this wave, part 1, the wavelength, and part 2, the amplitude. Let's go with the wavelength first. So as for the wavelength, you gotta have one complete wave, which is from here and forms an S shape up till that number 60. Okay. So the wavelength for this wave is 60. Okay, next part 2. Part 2 is the amplitude. Now, how we determine the amplitude is by using this from the peak through the center of the wave. So we need to see up till here only. So the value here is 8 mm. Okay, next, part B. Waves on the surface of the water are transverse wave. What is meant by transverse wave? Okay, this is a factual question. So a transverse wave is particles. Oh dear. Okay, particles of waves traveled in perpendicular direction of the wave direction. Okay. Next, question 14. Regions of the electromagnetic spectrum are shown in figure 14.1. Okay, here's the figure with the spectrum. Name the region in the spectrum labeled A. Okay. By facts, this is infrared radiation. So A is infrared radiation, or just keep it as infrared light. You can do that also. Part B. Which region of the spectrum has the longest wavelength? Okay, try to remember this way. You're gonna draw the longest one starting from the radio wave till the gamma ray shrinks. Okay, so your answer will be radio waves. I do this because it helps me to remember. Okay, part C. All the electromagnetic waves travel in the same speed in a vacuum. State the magnitude of this speed. So the speed here is 3.0 times 10 to the power of 8 meter per second. Okay, the units are already there. Next. Question 17. A wooden block is pulled across a horizontal table at a constant speed of 0.2 meter per second as shown in the figure 17.1. You can see right here with the forces right here. The block is pulled a distance of 0.8 meter by the horizontal force of 4.0 Newton. Part A. Calculate the time taken for the block to move 0.8 meters. Okay, you are asked to calculate the time. Okay. Time is, we don't know. The distance is 0.8 meters. We know the force. And then we know the speed. Speed is 0.2 meter per second. Okay, with all this information, speed is equal to 0.2 meter per second. Distance is 0.8 meter. And then time, we do not know. Okay, using the formula, speed is equal to distance divided by time. Swap the speed and the time around, so you get So you will get time is equal to distance divided by speed. So time here is equal to, the distance is 0.8 meters. Divided by speed is 0.20 meter per second. Meter is cancelled. So with the use of calculator, you get 4 seconds, which you can write here. Okay, now next, calculate the work done by the force 4 newtons to move the block through 0.8 meters. Okay, recall the formula. Work done is equal to force times distance. We know the force is 4 newtons. Substitute in 4 newton. You have distance is 0.8 meters. Okay, use calculator and you'll get 3.2 joules. Okay, so it's 3.2 with the unit joules. You can write J only, or you can write the full name of J or joules. It's up to you. Okay, last question, question 19. Figure 19.1 shows a swinging pendulum in 2 different positions. At position A, the pendulum bob changes the direction in which it was moving. So you have pendulum here, position B. Okay, you're asked to state the energy change that takes place as the pendulum swings from position A to position B. Position A, if you compare to position B, it has a certain amount of height. So height is always associated with potential energy. So when it moves to position B, it is moving. It has velocity, or it has speed. So speed always deals with kinetic energy. Okay, so the answer is part A. Part B. The period of the pendulum is 2 seconds, or 2.0 seconds. Calculate the shortest time for the pendulum to move from position A to position B. Okay. So 1 period is equal to 2.0 seconds. This 1 period meaning full oscillation. One full oscillation, let's go back to the diagram here. One full oscillation meaning from position A to position B to position, let's say it's C here, to back to position B, then position A. So it goes from here to here. So the distance from A to B is only 1/4 of the complete oscillation. So let's go back to the question. So A to B is only 1/4 of the full oscillation. So substitute the period or the time here. 1/4 of 2 seconds here will give you 0.5 seconds. So the answer or the time is 0.5 seconds for it to move from position A to position B.